Liquids, we can give an example of liquids like juice, like milk, water. Okay, they are in liquid state of matter. Okay, now there are still particles within these liquids. Okay, but the particles they also have forces that pull them together, but these forces are weaker. As a result, they are close together, but not tightly close together. Okay, and they are able, since because of the weaknesses of these forces, it is easy for them to slide past each other. If, say, I have a colleague here and they tie us with a rope, okay, so tight, none of us can easily move around. Okay, it means that our movement is very fixed. Now, I assume they tie 10 of us like that. We shall be like that. We cannot, we cannot shift very easily. But if they maybe loosen slightly, we can slide past each other. Okay, so the same thing applies even to the liquids. The particles in liquids Let's give another example. Assume we're in this room. If it's just the two of us, we have a lot of space. If they add 200 more people, we shall be closely packed together so that you can't even move to the left, to the right, front or back. You just stay. Have you ever been in a car where they park all over you? You know what I mean. You can't turn, you can't move. All you can do is look. Okay? And when some people get out, finally you can move, you can shift, So, where particles are not too closely packed, they have the ease to slide past each other. Okay, so we have said that particles in liquids are held by weaker. Intermolecular means between molecules. By molecules, we mean those particles. Okay, that's just another word. Forces of attraction, and therefore they are not tightly packed. Okay. So, because of this, now liquids are incompressible, cannot be compressed. They flow easily. This is what we mean. I have a liquid here, okay? I have another one here. This is water. This is not sanitizer, okay? So I have water in this container here and this container here. Since I don't have a third hand, let me put one down so that I can hold another. I also have water in this third container. Which of these do you think is bigger? Which of them do you think has a higher volume than the other? Maybe this, maybe this, maybe this. Actually, all of them have the same volume, okay? For example, This is about 3/4 of a cup, and if I add this one here, it's about the same volume. Okay, 3/4 of a cup. Yet it looked too small. Now the point here is that they never change volume. Whether you put it in a big container, or you put it in a small container, or you put it in a container that has no shape, it will always take up the shape of that container. If it is like this, if it is wide, if it is narrow, it will always be the same volume. But it will take up the shape. No fixed shape, but fixed volume. Solid, fixed shape, and fixed volume. And now we can go to the third state of matter, which we're going to refer to as gas. Do you know gas? Yeah, I am sure you know cooking gas, right? Of course that is gas too, but at least if you've seen balloons, maybe blown into them or used something like a pump to blow into them, that is gas. Okay, now we will still talk about particles that make up the gases. Okay, now these particles have very weak forces of attraction. Okay, assume my other colleague, the rope they used are the forces of attraction. Okay, that hold us together. So my friend, they tied us too tight. Then they loosened a bit so that we can slide past each other. You know, shift a bit, change position, liquid. Now, imagine if they actually even loosen it the more, so that it no longer even binds us, so that we can walk freely anywhere we want. Okay, so that is what gases look like. Gases have very weak forces of attraction, to the extent that we can almost say they don't have the forces of attraction. So this is the summary of the characteristics of gases. Okay, they have said that their forces of attraction. By negligible, we mean we can almost consider that they don't have, forces that attract them together. Okay, by negligible, we mean we can leave them out. Yeah? We can almost leave them out. Then particles are very loosely packed together and therefore can flow in any direction. That is why if say you lose a balloon, you untie it, gases will come out in all directions. Okay? If you have ever been to a concert or seen one on TV where they use smoke, that smoke goes everywhere at once, which is not very easy with liquid. When you pour like this, they'll pour like that. They won't be, going anyhow. They also have no fixed volume, but take up the volume of the container. If I have a gas, okay, let me bring back my containers. Of course there is air here, inside here, okay, because air can freely move even here, okay, even in a bucket. Now if I put air into this, pump air into my bottle, it will take up the shape of the what? Of the bottle. If I find a way to close this and put some gas inside, it will also take up the volume. Okay, so if this is about maybe 2 liters or 1.5 liters, or cubics, maybe 1.5 liters of space of volume, it will take up that much. If I take it and put it in a basin of 10 liters, it will still fit there, because they always fill up whatever container you give. Even if it is a balloon and I blow in a small amount of air, that air will fill up the balloon, okay? And we have said that they can be compressed. By that, have you ever been to a pump, maybe at a fuel station, or a bicycle where they are pumping air into it? Someone pumps and pumps. It grows and grows and grows. That comes a time where it is almost full, so they keep pumping. What happens is that the air that was there is squeezed to create more space for the incoming one, so they can be compressed, they can be squeezed, okay? Yes, that's how they fill gas. You know, our cooking gas, they pump more cooking gas into it, yeah, because those particles can be squeezed. And so those are the characteristics of our 3 states of matter, that is to say, solid, liquid, gas. And here is where I can maybe ask you to think with me. What state of matter is cooking oil? What state of matter is dust? What state of matter is porridge? What state of matter is fire? Okay, that is for you to think about, food for thought. But at the moment, for now, we shall now go to changes of state. Okay, change of state from solid to liquid, from liquid to gas, from gas to solid, like that.